So thanks everyone for coming. As the slide says, this is C++ for cross-platform VR, and I'm Nick. It's great to be back here on the east side of Seattle after being gone for a couple years. I used to work at Microsoft. And like we were just chatting a second ago, so to get an idea, how many of you guys have made VR apps or games? All right, so just the one lone guy in the back. All right, so I mean, hopefully this is informative then. I think it's relatively high level, so everyone will be able to learn at least a little bit of something. And I know this is the last talk before the dinner break, and everyone probably wants to come back for the 8:30 Grill the Committee. So I'll try to get through this quickly, and also I'll pepper this with some food recommendations from my time here in the East Side. Also as a bonus, and like I was just doing a second ago, you can check out some demos in the Gear VR. I brought it here. This is a contest that Oculus and OTOY, where I work, ran called Render the Metaverse. There's some pretty cool scenes that give you a sense of what's capable on today's HMDs. And feel free to check it out after the talk. So we're all here to, well, I guess to learn, but VR development isn't easy, and the stakes are actually quite high. And the reason the stakes are high is because getting it wrong causes nausea, and it's not just a little bit of sickness. You can actually leave someone sick the whole day. So with a normal application or with normal software, if you have some performance issues, the worst you'll get is an annoyed person. But in this case, you can actually cause someone to throw up. In addition, there's actually kind of non-trivial technical challenges that support a variety of operating systems: Windows, Linux, Android, PS4. In addition, there's a ton of devices. They all have different capabilities, CPU capabilities, graphics, and every SDK is different, sometimes actually in different languages also. And then finally, really great VR experiences rely on some form of input. And the problem is all the vendors are kind of competing over what the controller of the future will be. And to support all these input devices is quite a challenge. And then finally, and probably the most annoying thing of VR dev at the moment is these are just alpha and beta SDKs. There's still tons and tons of bugs. It crashes all the time. So it's not exactly the smoothest development experience. So poor latency leads to poor VR experiences. It's a driver, like I was saying, of simulator sickness, which is when someone experiences VR and they end up getting sick. And the latency requirements for VR are quite high. Most games are okay with 30 frames a second, and some maybe go as high as 60, but certainly 30 is not good enough for VR, and 60 starts to be just the borderline acceptable. We want significantly higher frame rates than 30 or 60. In addition, today's devices are also quite high resolution, so the GPUs and the software has to push quite a lot of pixels. Games and apps today don't have to deal with these types of resolutions, and VR apps and games do. And actually, to make things worse, all the manufacturers are competing along resolution and frame rate axes. So today, basically everyone is around 1K per eye and around 75 hertz. Some have more, some have less, but the ideal future, and this is also courtesy of Michael Abrash, is 16K per eye at 1,000 hertz. Now, these displays won't be around while we're alive, but this, endless march towards higher and higher resolutions and faster and faster frame rates will continue for quite some time. It turns out that the bar for recreating reality is really high. So all these things make C++ kind of a well-suited language for the job. C++, one of its strengths, and certainly one of the reasons it's having its second renaissance now, is that it's cross-platform, gives you really tight control over performance, it's suitable as a library, and then finally it has good interfaces to other languages, which is important if you want to rapidly prototype or you want to interface with designers and artists. As a bonus, almost all the SDKs are primarily C++, so this is probably a good sign that most of the kind of big minds in the industry are thinking C++ is the right language for the tool. Like I was mentioning, we'll take a quick breather here. This is food tip number 1. So as many farms right down the street. They make really good apple juice. It's worth checking out. I can't recommend it enough. Yeah, it's worth it. So, like I've been saying, VR development is quite difficult. So are there any solutions? I don't really have any, but instead what this talk is going to cover is approaches that I've tried over the last couple years on a variety of platforms and SDKs. And some of the results have been good and some of the results not so good. So how's this talk going to progress? I'll start with discussing the separate code base approach. This will cover Oculus Mobile and Cardboard. Then I'll discuss how to turn these two separate code bases in two separate languages into one shared code base that's entirely C++, and in the process cover Oculus Desktop, OpenVR, and PlayStation VR. And then finally, as a final note, we'll discuss how to add a quick little scripting layer on top of the C++ library we'll build up to see how to kind of rapidly prototype particular UI experiments in VR. So all VR apps effectively look the same, and this actually looks similar to a game also. The skeleton is you initialize some stuff, and then you have some kind of run loop, and you get frame callbacks, or you write your own frame callbacks. And then when you're done, obviously, you shut down and clean things up. So on Oculus Mobile, it's C++. Cardboard is Java. And when it comes to initialization, since they're both on Android, we have to do some Android lifecycle management. We have to do, obviously, some of our own C initialization. We'll leave the OpenGL stuff, the details of it, to the SDKs. And then finally, if our app needs it, we'll have our own loaders, resource managers, etc. Inside of the run loop, which for both Oculus Mobile and Cardboard will let the SDK handle for us. We'll handle input, update our scenes as necessary based on user input or based on what the user's looking at. And then finally, we'll draw once per eye. And then unsurprisingly, when the app is finished, we have to tear it down and return to the OS without any crashes. So what does this look like for a Oculus mobile app? We subclass, in this case, from VR app interface. And following the skeleton from before, we have some initialization. We have some drawing. We get a frame callback. And after the frame callback, draw eye view is called twice. And then finally, when it's time to shut down, we shut down. And of note here, Oculus also supports what are called hybrid apps, which means apps that work in VR mode, which is when the phone is plugged into the HMD, and also apps that work when the phone isn't plugged into the HMD. So a library browser, for example, is an example of that. So how does this look like with a Cardboard app? It looks basically the same. This time, obviously, we're in Java. We init. So one common theme with all the initialization, we get some configuration parameters. Once again, we have a frame callback and then two eye callbacks. And then when things are shut down, we have to go and clean up so the app doesn't crash and return successfully to the Android home screen. So what does this look like in practice? One of the main things that all the SDKs provide is what's called tracking. And that's the position of the head in space and along with the orientation of the head. So it's what you're looking at and where your head is. So in this case, we're seeing what the Oculus struct looks like. This quaternion stores the orientation, and this vec3 stores the position. And actually, of note here, when it comes to the mobile SDKs, no mobile SDK at the moment provides the position of the head in space. This is still a large open problem that no one has yet been able to figure out. So this is a kind of more in detail. How are we going to use these frame callbacks to actually do some drawing? So one of the key functions you have to implement in a Oculus mobile app is this frame. It hands you the VR frame, and inside of VR frame, we have the head pose. So since frame is called, unsurprisingly, once per frame, we might want to update our scene, update UI, but most importantly, we want to store off what comes inside of frame, which is the orientation of the head. And then after frame, draw eye view, unsurprisingly, gets called twice, also with some parameters. And inside of draw eye view is where we'd find the usual kind of OpenGL commands with the pose that we saved off a second ago. We can calculate model view and model view projection matrices, and then obviously do our drawing of our scene per eye. Another quick breather here. I know I'm trying to go through this quickly here so that you guys have a chance to eat. Right down the street is facing east. This is walking distance. Both these restaurants are. It's really good. And Mediterranean Kitchen, also right down the street, also really good. Can't recommend either of these high enough. It's better than McDonald's. All right, so back to our story here. So the state of the world at the moment is we have two separate code bases. We have Oculus Mobile in C++, and then we have Cardboard in Java. And it'd be nice to have one combined code base. And in addition, the more code bases we have, the more problems we're going to get into, the more platforms we want to support. If we have one code base for each platform, things quickly can get out of control. And like discussed a little earlier, we have at least 3 more platforms to support. OpenVR, PlayStation VR, and Oculus Desktop. So how can we do this? Again, we'll turn to our VR app skeleton, the concept of really all these VR apps. We init, we have a run loop, and then we shut down. So in this case, we'll move everything into entirely C++. When it's appropriate, we'll let the SDK init the window, OpenGL, and iBuffers. So in the case of, for example, Oculus Mobile, it's convenient to do so. And then we'll do our own init and textures, loaders, etc. So similarly, we have our per frame callbacks. We'll let the SDK do the buffer swap, distortion, and time warp. That's a common theme across all the SDKs. As usual, we'll get the head pose from the SDK. That's what we use to draw our scene and respond to input. Little side note here, some of the SDKs manage or at least provide a run loop for you, and some don't. And we'll see which ones do and don't a little bit later. That is, in either case, an option. And then as usual, nothing surprising here, we just shut down. So how does our new cross-platform class look like? Following the same themes, init, frame, shut down. We have configure, initialize, and entered VR mode. Rather than having platform-dependent types, we have our own settings and launch config. And since Oculus Mobile supports this notion of a hybrid app, we'll also have this enter VR mode and exit VR mode. We'll have our frame, and also we'll draw per eye. We'll handle input as it comes in, and we'll leave VR mode when appropriate. User takes the HMD off, or we'll shut down when the user closes the app. Nothing surprising here. So how can we do this structurally? One suggestion is to, rather than have if-defs inside of many files, instead we'll limit the if-defs to the header of VR application. And for each one of the different platforms, what we'll do is make a different translation unit. So here we have Oculus Mobile with the Oculus Mobile specific types, VR frame. And in a separate translation unit, we will define and use that function appropriately. So what does Cardboard look like? Since it's in Java, we can't avoid using the JNI, and you get these nasty looking functions like this. Sadly, it's the only way to do things. And actually, I found a humorous comment on the Oculus forums. So the guy that's responding here is Chris Pruitt, which is kind of the face of Oculus mobile developer relations. And you can see somebody asking him if there's going to be a Java API for the Oculus mobile SDK. And his response is, you can use the JNI if you're brave. I found that candid for developer support. So like I was saying a little bit earlier, some of the SDKs provide you a run loop and some don't. OpenVR is one of the ones that don't. And so in this case, our VR application is going to have its own main loop. This will be a standard loop. Effectively looks like while the app is running, go do some stuff. So how do we get the kind of important VR things? And this is a theme that we'll see across the OpenVR SDK, Oculus mobile and desktop SDKs, PlayStation VR, really all of them. It just comes down to tracking, which is where is the head in space, what's it looking at. It'll provide distortion based on the optics. And if the SDK supports some kind of input device, like many of them do, it will give you events to those. In this case, the OpenVR SDK does exactly that. So the PlayStation VR SDK is the exact same. We also have to implement our main loop. And unsurprisingly, it has its own little libraries that give you all the usual VR stuff that we've been talking about the whole time here. So what does Oculus Desktop look like? Same deal. What's interesting about Oculus Desktop is that it is quite different from Oculus Mobile. I'm not sure why that is, but it certainly potentially points to the fact that it's not easy to get cross-platform SDKs, cross-platform apps right. The apps and the SDKs for Oculus Mobile and Oculus Desktop are almost incompatible. But at any rate, the themes are the exact same. We have a library, here it's libovr. We have some initialization. We get tracking, and we submit a frame to the SDK, which will then do the distortion for us. And then finally, and as usual, we shut down. So another common theme here is that all these platforms are really the same, but they're all trying to do things in slightly different ways. And this kind of is reminiscent of old platform kind of graphics API wars. Ideally, at some point, there'll be some standardization. I think that's part of what Valve is trying to do with OpenVR. There are some other efforts like OSVR as well, though OSVR really hasn't gained any significant steam or traction. So finally, what we need to do, or we'd like to do, is add a scripting layer on top of our C++ library, and we'll appeal to the same concept as before, which is init, frame, and shut down. So this time we'll have primarily C++, and we'll add an additional scripting layer. The candidates at the moment are still up for debate. At work, at OTOY, we use Lua. But I think potentially another good idea is JavaScript, just to appeal to developers or web developers in a language that they're comfortable with. And another candidate is Scheme, which Carmack is calling, John Carmack, the CTO of Oculus, is calling VRScript. And in a couple days, apparently, he will be doing a demo using that at Oculus Connect. So some interesting experimentation happening in scripting. And one of the reasons that the scripting layer is nice on top of C++ is that for apps that aren't super performance intensive, and in addition, for apps that are UI driven, having a scripting layer makes it easy to prototype different UIs and also to separate the work between the people working on the C++ level stuff and designers and artists working on the higher levels. So in the long term, it's likely that some mix of C++ plus scripting layer will be the way that most apps are developed. And curiously, or maybe unsurprisingly enough, that's exactly what Unity and Unreal are heading towards. Unity primarily using C#, and Unreal using their blueprints, scripting, whatever it is, language / drag and drop UI. So how do we do the scripting? Well, it really depends on what we want to script. And for the layers that are script kind of prohibitive, which might be the core rendering loops, we'll avoid that. But for layers like maybe responding to taps or creating objects in a scene, or even for networking between these devices, scripting is a good candidate. And for all these things, when we want to call from script into C++, we can set up some handlers for that. And then similarly, when we want to call from C++ into the script, we can set up callbacks. I found this to be most useful in initialization, and like mentioned a little bit earlier, in responding to UI events. And so finally, what are the frontiers here, and kind of what are the lessons learned? One of the problems is that there's no real standardized and uniform way of implementing these VR apps. At a high level, the init and frame and shutdown pattern is common to them all, but everybody does things slightly differently. And as a result, you actually end up with quite a bit of code for each platform that feels like you're doing the same thing, but in slightly different ways. One of the kind of next work items, things that planning on trying next, is having uniformity with the run loops. So on Oculus Mobile and on Cardboard, you're relying on their SDK to manage the run loop for you. And in an ideal world, you either standardize on the SDKs doing that, or you standardize on yourself doing that. And it seems, given the fact that most of the SDKs don't give you a run loop, writing a run loop for Oculus Mobile and for Cardboard might be the way to go. What would also be nice is to try out other scripting languages. When talking with other developers, I've heard suggestions of even C++ scripting. It'd also be nice to make the C++ components increasingly modular. Right now, the code is, or as described, the code is very heavily dependent on C++, and as a result, it's difficult to separate things from one another. One of the reasons that that's required, and this is how the modularness is tangled in with the uniformity and all related to cross-platform, is everyone's ultimately doing the same thing. They're all effectively providing tracking information and providing some kind of distortion, but everyone's doing it slightly differently. So this is a common problem on mobile platforms, which is each one of the mobile platforms provides their own kind of set of UI widgets. And if you want an Android app to look like an Android app, then you have to make sure that your C++ library interfaces properly with the Android OS. And similarly with, if you want an iOS app to look like an iOS app, you have to use the iOS widgets. And this hasn't quite happened yet in VR, but you can already see signs of it as these SDKs are starting to standardize. So for example, the Oculus Mobile SDK has its own set of widgets, and it encourages you to use those widgets. And then I'm guessing over time, an Oculus Mobile app will start to look like an Oculus Mobile app, which won't look like a PlayStation app, which won't look like an Oculus desktop app. What that gives you, or the problem that creates, is it makes it harder to create cross-platform apps that look native to that platform. So on the one hand, you have the nicety of being able to use these widgets, and on the other hand, you have the hassle of having to deal with one standard interface to a whole bunch of different widget types. And then finally, all of these VR experiences and platforms are trying to create their own input devices. And as a result, it makes it very difficult to write code for all of them. So perhaps in the long term, there won't be a uniform VR input device. But in the short term, what this leaves you is having to write code that deals with controllers, that deals with certain kinds of wands, that deals with the PlayStation Move, the Oculus Touch. There are rings. The Leap Motion uses your hands. So everyone has its own idea, or everyone has their own idea on what the right model is for VR input. And no one really has given any tremendous thought on kind of standardizing what that might be. So an example of kind of what might go poorly if there is no standardization or no attempt to come up with like what is the basic VR controller is, imagine if Sony and Microsoft hadn't agreed at a high level, what does a basic console controller look like? You couldn't write games for both consoles. You certainly couldn't design them and design them well. So if there isn't some kind of, this is what a general VR controller looks like, the design of VR apps will suffer. And then as I've talked with people, the counter argument is like, sure, while Microsoft and Sony have in principle agreed what a console controller should look like, there are still a variety of devices that attach to consoles. Obviously, Microsoft's got the Kinect, but then even there's things like the Rock Band guitar and the drum set. So it's possible that in the end, what happens with VR is people decide there's a general kind of wand, like what Valve and Sony have, and for each unique VR experience, sometimes you'll have something different, and maybe sometimes you use your hands, but ultimately, when it comes down to designing the experiences for these things, you'll have to design the experience with the input in mind. And then finally, as the last little breather here, so I don't know if you guys have noticed, in almost not every one of his talks, but a common theme in Scott Meyer's talk is him asking about pizza. So Serious Pie is my favorite pizza here in Seattle. That one's not super close to here, but it's definitely worth the drive. And I recommend the buffalo mozzarella pizza there. It's quite good. And so it looks like we got through this quite quickly. And thanks for listening. Any questions?
The cross-platform framework is like a lead time substitution for the different kind of things.
Yeah.
Not inheritance and subclasses.
So there's no great reason. So you could have, for example, like if we go back a couple of slides here. So you could have, I think what you're suggesting is, so for like say PlayStation VR, you'd subclass VR application and just say PlayStation VR app or something like that. Yeah, there's no great reason. What this gives you is the ability to, so say you want to have like one global object, like it's a design pattern called like the program, global program, I guess. That's common in games. And so say you want to have something simple like you have a global program object that's used in all the apps, and for each platform's run loop, you don't want to have a separate type. So you say you want to have the run loop in a standard file that is in a layer above your platform layer. In that case, you'd have to if-def inside of the run loop. In this case, you could just go VR application .frame and then hand it some stuff, or drop RI. But ultimately, it's a design choice. Yep.
Can you talk a little bit about the audio stack for these devices?
Yeah, so just like everything else, audio is SDK specific. And everyone does things a little bit differently. A, because of the differences in OSs, and B, because the industry is so new. And C, I think it's just some level of kind of everyone wants to build their own walled garden, and everybody wants to be the dominant VR platform. That said, it is something that is and kind of under active research, because like I was saying earlier, or I was mentioning earlier about the simulator sickness, one of the ways that you can prevent simulator sickness is by having positional audio. It significantly, for some reason, impacts just how sick you get, especially with things where you're moving quickly through space. So I guess it's not a tremendously good answer other than, it's under active development, and everybody does it differently.
What is it? Is it a callback model? Is it a push model? Is it a pull model?
They all provide kind of, I guess the best way to say it is they all provide an SDK, or they provide a way for you to give like 3D positional audio, and everybody does it differently. In some cases, you'll provide a wave. In some cases, if you just say like a video, for example, a 360 video. And in some cases, you'll actually provide, where the object is in space so that it can calculate properly, what ear to play it on. Yeah.
So the Sony Morpheus has an RGB display, while the Oculus can get mobile headsets to have a pentile subpixel matrix display. Is there a way to optimize rendering for those displays? For example, only running half the red and 2 pixels in that case.
So you're asking on the Sony, sorry, can you repeat?
I think the Sony Morpheus has an RGB subpixel matrix on their OLED displays, and Oculus devices or Oculus-based devices use a pentile matrix, which have only half the red and blue subpixels. So is there an efficient way to somehow optimize rendering for that to gain a little bit of speed on those devices?
Okay, so what you're asking is the Sony Morpheus display is inherently different than the rest of the displays.
Yeah.
And are there any differences, or are there any ways to optimize or take advantage of that? That's a great question. I'm not sure, actually. What I have heard, and I don't know that it's an opinion that like I have kind of strong. It's not that I disagree with it. It's that it's just something I've heard. People are very kind of how to say it best. People really like the Sony display, and they really think it's the best one. So maybe that's one of the reasons, but I'm not sure. Yep.
Can you go into a little bit what would be involved in switching out the scripting language for the application, like if you were to transition from Lua to JavaScript?
Yeah, I mean, just like everything else. Oh, so sorry. The question was, what would be involved in switching from Lua to JavaScript, or to whatever language of choice? And in some sense, just like everything else, it's platform dependent. So on Android, you might use the Android OS JavaScript interpreters. You could also add, like some apps are doing today, V8 directly into your app. So the final kind of interesting component when it comes to that, and especially in regards to Lua, but just scripting languages in general, some of the platform vendors or some of the kind of VR vendors don't allow jitting on their platform. Presumably they say it's because of security reasons, but kind of that's what they underline, but maybe the real reason is that allows you to maybe put your own app store on their platforms. So I guess ultimately the best way to answer your question is it depends, just like everything else. There's no great answers. VR is kind of Wild West at the moment. So if you're interested in it, you should definitely work on it. Anyone else?
Can you say which ones don't allow JITs on their platforms? Specifically V8 JITs or JavaScript JITs?
Yeah, actually, so I'm not sure what the PlayStation uses for JavaScript JIT, although they do allow it. I'm not sure what engine. What they don't allow is they don't allow Lua JIT. Yeah.
Historically, they've used JavaScript Core for everything.
Yeah.
So just the standard WebKit JS JIT.
On the PlayStation?
Yeah.
So a good example of that, and this doesn't really have much to do with VR, is, for example, like iOS doesn't allow jitting inside of an app.
Right when you embed a web.
If you embed a web view, it does, yeah. But if
No,
you,
no, it's the opposite, because the Safari browser itself totally has jitting.
right,
You run browser like JavaScript benchmarks, and
Yeah.
Safari, iOS 9 is like twice as fast as iOS 8 was on even an iPad 2, like really old hardware.
yeah,
On Sony, the Vita and the PS4, the JavaScript core that they embed in their browser apps is interpreter only. But
Oh, I
the
see.
private use of it has a JIT turned on. So I was curious, like,
so we haven't tried this yet, but I do remember reading somewhere in the documentation that they do allow JavaScript JIT inside of a PlayStation app.
is that because they control the JavaScript?
Presumably, yeah, exactly, because they use some engine of choice, and maybe they run it through some like pre-pass to make sure that you're not doing something they don't want you to do. I'm not sure. They definitely don't allow Lua JIT, though.
On the back to VR, on the mobile platforms, does using a scripting language that does have a JIT help with the performance of the mobile platform, since a JIT is just going to be inherently more performant, like better performance per watt, effectively,
Right.
for the same code than a non-JITted pure interpreter?
Yeah, so if we're not talking about VR anymore, just mobile development.
No, I mean VR mobile development, like for the Samsung device we have and stuff like that.
So what you're asking is, just to repeat the question, does JIT, or the ability to JIT on a mobile platform, in particular the phone, or these Android phones, which are the only ones supported at the moment, give any like battery life or performance gains?
Yeah, for VR applications specifically.
I haven't measured that, but presumably yes, and certainly there'd be performance implications. So say you wanted to do things that aren't just responding to user events. Maybe you want to create a bunch of objects, or maybe you want to add some scripting into the kind of the main run loop. You would definitely want jitter in that case. Does that answer the question?
Yeah.
Anyone else? All right, thanks. So we got here a little early.